Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
And, we don't hear, John with us this week. And, we'll go ahead and, first and foremost, say, hey, we're sorry that, we didn't get to you last week. We had a little bit of a run-in with Little Debbie. A little windy, but, none the same. So, so we've been talking a lot about, the influences of robotics and stuff like that. We've also talked about how we use robotics in manufacturing. However, I kind of want to get on to the point of talking about how does 3D printing support robotics? So, how, when you're talking about end-of-arm tooling, you talk about jigging, you talk about any of that type of stuff. So, when we start talking about, 3D printing support too, what are you thinking?
Well, like I said, the main thing you said, as far as if we're talking about how we use 3D printing in conjunction with robotics, one of the biggest things is like saying tooling. So tooling or end-on tooling, to be more specific, you can do a lot of things with 3D printing. So you can do prefab, where you can do tests to see if the end-on tool is within tolerance. You can see if the end-on toolings would have any interference with the, tooling that you're using to hold whatever product you're trying to manufacture. I would say another thing you can use it for is you can also use it for jigs, like if you want to do teaching or if you want to do mastering. You could 3D print things to do that. You could also look at it from another point of view. You could 3D print the base plates and see which configuration would work for you. And then I would say another way you could use it is actually using the robot with 3D printing, far as combining the two.
Yeah, makes
and
sense.
The overlap of the two together.
And and I think you hit the kind of hit the nail on the head. But we start talking about it's good thing about 3D printing is the rapid advancement of R&D. The fact that now I can take a CAD model that I have in my system, make it real, put it on the robot, make sure it works before I send my CAD drawing and my end-of-arm tooling that I've created with 3D printing to the manufacturer to build, if I don't have on-site CNC or on-site fabrication support. Because then it's a verification of R&D. But also, I was kind of thinking about this. We start talking about grippers and stuff like that. We start talking about the fact of how much force these grippers have to put on a piece of material that it's picking up. It's using 3D printing to calibrate grip force. So using that, because the thing is, if you start talking about the different infills in 3D printing, each one's gonna have a different crush ratio. So, and the thing is, so you would use that to actually calibrate the crush forces to make sure that, hey, guess what? It doesn't crush it too much. It doesn't crush it too little. It's available to pick something up. And, it might be a little different if you start talking about like really thin sheet metal. However, but if you're talking about like thicker pieces, like for example, if somebody is using a gripper to move palletization robot, to move boxes around, now we can use that 3D printing to calibrate the box to say, okay, cool, this is what your cardboard box is. So it's calibrating the crush forces and stuff like that for when they pick it up and they move it from one pallet to another. In case they're doing like on-site development for this type of stuff. So not using one that's out of the box, not using a system that's already predefined or pre-built. They're controlling their own. So if they're doing like the 4-finger gripper that comes out, locks down top of the box, moves it from one spot to another. And the thing is so if they got to calibrate that crush force from all four corners, they can build the box with a 3D printer, make sure that's what they want, and send it on its way. And the thing is, it also helps, how I see it, is to make sure that you know, tolerances are yeah, they're okay. Because 3D printing, your tolerances aren't always there, depending on what you're using. Maybe if you're using like SLS or anything like that, but if you're using FDM, your tolerances may not 100% be to right where they think they are per se. Might not match the CAD drawing 100% depending on what type of printer you're using. So you can actually build in your wiggle room to your end of arm tooling for your adjustments.
So like, say if we go back to the picking up boxes application. So another way you can look at it. So most of the time when you're looking at in-arm tooling for picking up any type of box, like I said, there are things that you have to consider for us force. But a lot of times we use suction cups.
Oh, okay, yeah.
So the suction cup, and then you'd have a secondary action where you had a supporting member that would go under the boxes. So when you're supporting, say I'm moving 4 boxes at a time or 3 boxes at a time, it would move over. So what you could do, you could use 3D printing for making different type of suction cups to figure out, hey, can I make a more durable suction cup? Also, you could also figure out different ways to alleviate the problem of having the crushing force.
Yeah, makes sense.
So maybe I make a apparatus with pneumatics that I can go, instead of holding at 1 point, I can hold at 2 points. So now I don't have to have as much force to hold the box because it's sitting on a platter.
Yeah, makes sense.
So gripper picks it up, platter goes up under, and then we move it over. So you use it for things like that. You could also use it for, like you saying, I like, the ideal of a go, no-go gauges.
Yeah.
Say I have a gripper that has to pick up something that's a certain amount of millimeters. Now I can make a go, no-go gauge for a first part release with, say, a cell lock. And a cell lock can just take this part and it grips at a couple of spots, and that's each part that it has to deal with in that particular application. Another thing is okay, maybe we could 3D print tools that we could prototype that makes it easier to rapidly remove and install. So jigs.
Yeah, like jigging, yeah.
Yeah, so
Makes
we
sense.
use jigs to uninstall and reinstall things that we need. And then another thing would be maybe we could 3D print brackets that we could put smart sensors on, kind of like what we do with the CG.
Oh, okay, yeah, no trouble.
And we can use vision systems to see the
Like
tolerance
the
of the
4-point
gripper,
quadrants and stuff like
and
that.
we can
yeah.
print our own custom brackets to go wherever on whatever type.
So
of
kind of like the
gripper.
target system.
Yeah, a target system that you can have a vision system that comes over and say, okay, we're with intolerance, not intolerance. Hey, this one needs service. Put in the new one.
Because if you think about it, a lot of times, robots will go to the like what you're saying, they'll go to the show position. I'm trying to. I'm thinking about how that would be implemented, because now you got me curious. Is if you have a 6 to 8 cup suction cup gripper, if you're talking about putting targets on it, now what I would do is send the robot to show. It would go to show position. It'd come up. It would get scanned, make sure it's within tolerance, and to go back down. The thing is at that point, I would actually add an additional robot, maybe not a full-blown, full-size robot, but a smaller robot, into my process to actually scan, like a gantry robot, to scan my end-of-arm tooling that has the targets on there to make sure that my targets are within range.
That's an option that you can use. I'm not opposed to adding automation or adding robotics or adding anything. Typically, when we add robots, just as a rule of thumb, we add robots either to speed up the process or to reduce the cost of doing the process.
Right.
Those are typically the two applications. Or maybe it's something that a human can't continuously do.
Yeah.
Or it's something that's too dangerous for a human to do. Those are some considerations. So what I always think about is I always think back to what can we do simple.
Yeah.
I could just have stationary cameras
Like a Cognex camera.
pointed wherever, or we could go with a scanning system that actually scans the part, and we could, hey, maybe we don't need the robot because I can clip on these things. A cell op goes in,
Yeah.
clips on a fixture. That fixture has everything that's supposed to be where it's supposed to be. So it has all of the dots that's supposed to be in the place. My vision system, however I want to do it, if I want to do it with a robot, it's not out of the question. You know, you figure out what the cost to ROI is for yourself.
Right.
Or if I want to go simple and just have a stationary camera, it goes up to a stationary camera. Maybe I go with a stepper motor. Maybe I go with a pneumatic cylinder that says goes this way at a certain speed.
Yeah.
Or maybe I go with a linear actuator. Whatever the thing I want to use.
You know, with that, I would, it would be I would look at going towards Cognex. Because the Cognex cameras, I can take pictures. So before, start of every shift, come up, go to show, get a picture taken. And then you can take all those pictures and load it into a smart system that does for your advanced analytics and also for your preventive maintenance, and actually take that and actually tell if there's a change in the gripper for each station.
And you basically you're making a library you can use
Right.
without going down the rabbit hole. We use machine learning, deep learning,
Yeah.
AI, blah, blah,
we
blah.
can go down this.
We can do all that. But basically what you're doing is saying, hey, am I within a window?
Yeah,
And that's, to me, it should be a window system.
Yeah.
Hey, I built up a library. I'm comparing the library to where it's supposed to be. And all I care about is minimum max.
Right,
I only have
exactly.
to have really a bunch of pictures that represent two things. What is my min, what is my max? And nominal should be in between those two.
Right, exactly. It makes sense. And now, if you think about it, and this, I was kind of thinking about this also because we were talking about preventative maintenance. Using a 3D printer to support that, to support preventative maintenance, because a lot of times you see a lot of downtime from for robots and stuff like that because we can't find small parts, stuff we may need. So you start looking at like an SLA 3D printer that prints out of metal. It could print gas, it could print your fittings and fixtures and stuff like that all day long without even breaking a sweat. But the thing is you start getting into FDM printers or SLA printers or stuff like that, and you can start making gaskets. You can start making, stuff that will go bad, and you can actually start building your inventory of spare parts just with a rack of 3D printers. The thing is I guarantee you there's robot companies out there saying, don't say that, because people are going to lose money, because guess what you could find easily is the CAD drawings for this crap, and throw it into a 3D printer and say, good luck. Yeah. So, it's, because you think about it, you start talking about like shear fittings and stuff like that, air fittings and, whatnot. Small little things that when they go bad, they always go bad when you don't have any left.
Yeah.
You're never trying to find a grease fitting that's going to go bad when you have 30 of them.
So I would say, this is what I would say. The technology is advancing rapidly, and we're getting closer to that reality. When we start talking about pressure fittings, grease fittings are a little different because grease fitting is under a certain type of parameters. But when you start talking pneumatics or hydraulics, we're talking about pressures that could change. Somebody could increase the bar.
Right.
Or somebody could increase the Pascals or whatever if we're using hydraulics or whatever.
Right.
If we're using a sealer application. normally that's a high pressure application. So what you have to consider when you're doing that, some things we can do, and it's a really great idea. Maybe even we go to the point that, hey, I can print the gasket material to a certain millimeter.
Yeah.
In the bed, that's easy for a bed.
Right.
As long as the bed is level, it can go and print this. Hey, I need 12 by 12 sheets of this material. In this thing can probably do it. Hey, I need this to go for. We're going to run 4 shifts of this. We take that material and then we take, and maybe we add that another application like a laser application that goes out and cut out the gaskets and the gaskets, and then a co-robot between the two that transfer the material from the additive manufacturing process to a subtractive process, and we're taking that and we're putting this in a bin, and here are all the gasket parts you need if you're building blocks for If you're building the engine where you have to
Yeah.
have a head gasket,
Yeah,
or
makes
hey,
sense.
here's something we need for a low pressure application. But we are rapidly getting to what you're talking about.
Yeah, I think we're almost there, like you said. I think maybe.
It's
Who knows?
getting there. It's
You know,
getting there. Maybe not the speed, but
Yeah.
the ability is getting there.
I honestly think that, when we go to Rapid next year, because we missed Rapid this year, I think when we go to Rapid next year, we're going to see a dramatic shift. And, what is the additive manufacturing space? Especially with additive manufacturing and support of or support with, a robot cobot environment. Because we've already seen images of 3D printers being loaded by robots, or unloaded by robot. I guess you really can't load a robot.
Well,
You could, if you start talking about SLA, you got to pour powder and all the other stuff.
but there's a possibility also.
Yeah.
I don't know if it's someone has thought of this. I'm just spitballing. If I can load a magazine with whatever,
Yeah.
why couldn't I develop the technology that I just load spools? I have a system that does what it needs to do. It does a calibration. Hey, what do I have on me? What material? Reads a barcode or whatever.
Yeah.
Roll it to the position. Auto load. And you can have an auto load feature built into the printer, and the cobot unloads and reloads, and that's all it does.
Yeah.
You build the other portion of that into your additive manufacturing equipment. It does all that.
Yeah, it makes
The
sense.
robot is just the person it's the attendant.
Yeah, I saw a video a while back, and I kind of brought it up to the folks at the robot at some of the companies at Automate. Is we've seen it where we've had a cobot on an AGV, and take that AGV, it goes to an SLA machine.
And mind you, an AGV is a cobot.
Right.
So a cobot on a cobot.
On a cobot, yeah. We're getting here, but and the thing is, we're almost to aliens. If they were single cell organisms. You never know. But never seen a tadpole. But the thing is, you start thinking about it. They were taking this AGV with this robot on it, going to an SLA machine, kind of like a FormBot AGV. No, not a FormBot AGV, but a SLA printer. The ones where the front door pops up. Then reach in, remove the plate, set the plate on a rack, load the next plate. Close the door. Then they would take this, they would load it to their rack, and they take their rack back to the demold station, where another robot would take it off of that rack, demold it, set the rack back into a cleaning solution, pull it out of the cleaning solution, and add it back to the AGV's rack again to be taken back and reloaded back into the station.
So sometimes we give people freebies.
Yeah.
Because we're more concerned with advancing additive manufacturing.
Right.
So I can tell you right now the biggest flaw with desktop additive manufacturing, and even small to medium commercial additive manufacturing. We're using spools.
Yeah.
Why are we using spools? We have processes where we take a barrel and put weld wire in the barrel.
Right.
Why are we not putting the material in a barrel?
Yeah,
And the barrel lasts for a week. Think about it.
Yeah.
You could do this in a barrel, and then the barrel is reusable.
Yeah, makes sense.
You can send the barrel back to the manufacturer. The manufacturer reloads the barrel, and they make a one-time cost of producing a barrel that's able to work with the material.
But at that point, if you were doing that, I would definitely I could agree with that, and I could get 100% behind that.
And it depends on how you want to scale the barrel. I'm not saying it has to be a 50 gallon barrel. It could be
That'd be an interesting purchase.
Yeah.
I can go different ways with that. You go look at Costco, you'll see some weird shit for sale. But the thing is with that is what I would do is I'd take all my bad prints, all the bad prints, and have robots dump them into by color and sort them by color using a vision system into the respective bins.
Then I'm gonna go one further.
What I would do is I'd take those barrels and ship them back to the manufacturer. They can grind them up and turn them back into filament again.
So I'm gonna go one further with you.
Unless it's
the robot puts it in a sorter.
Yeah.
We make a sorter that's intelligent, that knows based on whatever they do it. If we can print with colors, then that means we understand colors.
Yeah.
We could put those different sizes, however you want to do it, or you can just say I don't care about size, I don't care about color. We could put a scanning system in. Here's a bank, scan it, open which door. Hey, these are all red. Open 3 doors to go to red, and you have chutes that go to red. I mean, it's different ways of doing it.
Oh yeah.
I just like, for me, I like cost effective. Cost effective and low tech works for anything that's like low tech application.
Right.
So like sorting, that kind of stuff is low tech, but having a robot do this process, it's basically a machine attendant.
Yeah.
Hey, take this and put it over here. Hey, you do this. Hey, you do that.
Yeah.
But you could make it sort too. If you didn't want to do the system I'm talking about, which would be a little bit more cost effective for a small company, maybe a large company wouldn't care. I can just go with a different cobot, and his function is just sorting.
Yeah, I think that it's the idea of machine tending and 3D printing. I'm hoping it gets there because, especially for small manufacturers who are really getting into the space of additive, that's the next generation to happen is machine tending. You start talking about these SLA printers, for example, the metal 3D printers that run off of powder. That stuff is extremely dangerous. You have to put a respirator on to deal with it. Why do we have to have humans dealing with it? Pretty much, I would create a cell with a tending robot that waits, or tends multiple machines, and as soon as the print is done, it removes the basket, and it'll dump the basket because it has to dump it into a machine that knocks off all the powder into a safe bin, and then take that part and set it into a high pressure air area where they're actually they're kind of like sandblasting. But
see, that's where I was going to go with.
They might do sandblasting to clean it, but the thing is then you could take that powder that you just recycled, because all these printers have their own recycling system. Yeah. Recycle what you need, put it back. The robot will put it back, close the lid, and then they will then have that trigger the operator to say, "Hey, load the next part." Right. Or if you're doing the same thing, just hit the button and restart the print. Right. And the thing is now we have a human outside of the toxic area. Outside, because that, I don't know if have you ever seen the powder that they use in that 3D printing stuff?
I mean, I've watched videos.
We saw it at Rapid. Stuff's like talcum powder.
So this is what so we have a process that already uses powder like that. That's really fine. Yeah. That's a laser.
Yeah, powder bed fusion.
So a laser printer basically has a toner cartridge that has this powder in it. Right. The powder is put on the thing, and then you take a laser, blah blah blah, that does whatever. So I'm in favor of containment. All of the stuff that a human shouldn't have to be exposed to should be contained. Right. I mean, I am also for, why are we paying a person for 8 hours to put in stock and take out of stock? Why am I paying somebody to put stock into a CNC machine and pull out stock from a CNC machine? I would rather have the expertise of that person for improving path quality or making the program. Also, to do verification that, hey, we're getting what we want out of the machine. Are there any deviations? So the person should become more like an analyst, so a process analyst. And then the robot should take over all those things. But I do think the solution to what you're talking about, as far as the dangerous applications for, if we're talking hobbyists, or we're talking small commercial businesses that already do machining and they want to add additive manufacturing to their arsenal, then they should look at enclosed applications. Yeah. So you may have to purchase a commercial machine that encloses these things, like when you buy high quality laser machines,
Yeah.
it has a ventilation system, and you close everything, and if the door not closed, it won't start.
Yeah.
So maybe that's something we should look at when we start talking about using these more sophisticated additive manufacturing techniques.
And, you know, it's the part retrieval is always, you know, 95% of the issue, I think. You know, and the thing is, you know, and if you start thinking about it, you know, all of those additive manufacturing sides, you know, support the robotic side. Because for every 10 customer parts you print one repair part for the robot. You know, because things are going to go bad, things are going to wear. Well, wear points are going to happen. You know, especially if, you know, when you start dealing with, like for example, especially if you're doing SLA printing and stuff like that, and you're, you know, doing the powder bed fusion, and you have the wear markers on the end of the grippers. As those wear, your tolerances get thin, and your tolerances get wider and wider and wider. So what I would do is, if I'm using a robot like that to tend to my powder bed fusion machine, is for every 10 prints, I'm printing one that's for that robot. I'm going to print one set of covers that go over to make sure my tolerances are back to normal, so that I can bolt back in. Because then my tolerances never change. Because then I'm changing that before my tolerances now become at risk. But I'm always building an inventory of spare parts as far as high wear items to support my operation for the additive manufacturing side of the house. Because if you think about it, that talcum powder stuff is, you're talking titanium, or you're talking stuff that's very abrasive, very, you know, caustic, you know, stuff that can, if you're not wearing a respirator, probably not going to be a good day.
Right.
But that stuff, metal on metal parts, is going to wear.
Yeah. So
you're going to start seeing a whole, especially if you're using aluminum fixturing, is, you know, once you pull it, so, you know, why not every so often run a batch for that robot? You know, it might not, and the thing is, after a while, you're no longer replacing the parts on your robot with factory parts. So if you're running a batch of titanium, you're no longer replacing aluminum with aluminum. You're doing from aluminum to titanium. So now you've strengthened your robot. You've made the robot lighter. You've reduced weight. So the thing is, so now you're not just taking that build platform and replacing parts, wear parts. Now you're improving the robot, improving efficiency, because now the robot head's lighter. So it doesn't. So, you know, there's not a lot of strain on the motors anymore. You know, it's that type of stuff.
So I mean, those are all good applications of, you know, and that's a good example. So I guess I've been doing this type of stuff for so long. I've learned how to focus on when I'm presented with a problem. I have a abrasive material, and this abrasive material is causing wear.
Yeah.
So normally, I'll give you an example on heavy equipment. On the heavy equipment, the buckets and stuff, they actually add. They know that it's going to be a certain amount of time and a certain amount of wear,
spikes, yeah.
and they know to just have those on site to cut off. But I look at the application we just talked about with the abrasive powder. For me, if the issue is the metal to metal, or if the issue is this is an abrasive that wears, why not have it to where I've done my process, I'm finished with the part. When the part is finished, I dump the material below the part. I run a vacuum to suction anything that's left. And then all I'm dealing with is the part. So I do also agree with, hey, we should print some, I would say, repair parts or consumables or things that it's going to wear out. But I think we can mitigate how often we have to do that.
Yeah,
or we could print how much we need for a month, how much we need for a year, how much we need for hours. If we're talking, say, like in the petroleum industry, they know, or when we're mining or drilling or whatever for new taps for petroleum.
Yeah.
They know that those tips have a certain amount of time before they wear. So I think that could be some things that we can incorporate like I said, techniques of removing the thing that's causing the problem. Use technology like IoT or IoT to get data back, so that we can use things like a unified namespace where we can move these signals where we need when we only required to have them, and then we can actually do some analysis on that data, and we would know what we needed from it. So I think that's maybe something else that we're not thinking right now.
Yeah.
How do we make the system more efficient?
Right. And I think also the thing is, I think the one thing we haven't really talked about is, we talked about robotics. We talked about how it supports robotics. Is the 3D printing to the entire robot architecture. We start talking about robot architectures. We're talking about, cabinets, electrical cabinets, panels, and stuff like that. 3D printing to support the entire ecosystem, the robot ecosystem, is huge. Because you start talking about the fact you can start printing 3D printing DIN rail, non-conductive DIN rail. Because it's plastic. You're not going to conduct electricity through DIN rail, through that stuff. But if you're using, any other type of DIN rail that we're using now, it could become, attractive eventually. And then you have sparkly water. But, the thing is, we can use that system to rebuild, environments. As things wear. For example, your e-stop buttons. Why can I not 3D print the replacement for an e-stop button as the numbering wears, as people hit it or as people use it,
Right.
because
So I think that's a better application. I mean, the reason they use DIN rail or aluminum DIN rail in particular, lightweight, but it's the mechanical strength.
right,
And typically, most things, just from my experience, there's really a really low probability of ever having an issue with any metal component that's used for the back structure or I would say the back plate. Where you could have problems is if somebody incorrectly wires something. So if somebody incorrectly wires something, like hook the ground to the wrong place, then that's not going to be caught. But when you start talking about things like, the mushroom button that's used on a e-stop, we start talking about, hey, maybe we got some vibration components that we can use. I think that's probably more achievable at this moment.
yeah.
In the future, who knows what we'll
Right.
be able to do and how quick things will be able to be produced. So at the moment, I think anything that's dealing with like you said, hey, this could wear out or this could break. Hey, I have to order another one of these, or I have to order a whole nother switch and take this one apart. Or I could just 3D print this one and replace the part that's broken.
Right.
So I think that's a good application, and actually the molded part that we use for holding the contact blocks. I mean, things
Right.
like that. I think that would be a good application.
And the thing is, you start talking about at that point, you start really talking about like nylon shimming, stuff like that. How to shim, different things and stuff like that.
Yeah.
You can always 3D print the nylon shims, nylon them down, and then hit them with a subtractive manufacturing to knock them down to the exact tolerance you need. And the thing is, it's easy to redo.
That's a really good idea. Is to print one nominal shimming stock. Just print one size.
Yeah.
And then you do, like you said, you use the subtractive manufacturing process to shim it exactly
Yep.
to what you need by thousands. I think that I haven't seen anybody thinking like that.
Yeah.
That-
And you can print in polycarbonate. So you can print in polycarbonate. You can print in PC4 nylon. You can print in all this stuff. Yeah, you have to deal with your with your infills. However, if you're running 100% infill, like you probably would be, then you can easily machine that down
That's what I'm saying. I mean, if I just say all of my shimming stock is going to be this nominal size, I take it to a subtractive manufacturing process. It mills it to, hey, I need to be down this thou. It can easily do that, no problem. And then, like I said, you can use whatever cobot or whatever you want to use to pull it out, and I can produce a whole box or a whole kit that could go to each line or go to a cabinet that you can pull from, and I don't have to buy those stock. I mean, some things have to be steel, even with steel. once again, we can 3D print this to a nominal size and use this attractive manufacturing process to mill it to the right size.
Yeah.
I think that is a brilliant idea to use additive manufacturing for that.
And the thing is, if you start thinking about it, as you especially for like shimming and stuff like that, you start really dealing with a safety standpoint, because a lot of the times you get into some of these 3D printers that can print multiple colors. So now, like we were talking earlier, the high wear mushroom button, for example, most of the time it's just painted on. It's not printed all the way through the plastic unless it's on certain elements.
So the rules changed
Yeah.
about 5 years ago. So now you have to have a certain color
All the way through.
It has to be a certain color label on to the mushroom button
Oh, okay.
per the standard.
Yeah.
But you can print it red, and then you have to have the color.
Right.
And that color is across everything in the U.S.
But the thing is what I'm thinking is because, for example, we'll look at the Bamboo Lab. If you print with a Bamboo Lab, you can set your colors up
Oh yeah,
in your AMS unit.
Yeah.
And you can pick what colors you want that to be. So you'll never have an opportunity of where the white will wear off, where it says emergency, you'll never have a spot where it'll wear off here. So because it's that same color all the way through the part.
Yeah.
So you've now taken the issue that you have of it has to have the sticker on there. It has to be this. It has to be that. Yeah. Let me 3D print it all the way out, so it's one color all the way through the part. So you can use this thing for 6 to 8 months, or 6 to 12 years, and never have an issue with it because you're never going to wear through the color.
I mean, and you can also use different materials.
And if you're using the stop button that many times,
I can use one material, but normally they don't. Normally they break because of impact or normally. But you could have different hardness of materials printed also.
right?
So I could print most of the print out of this material, and then I could print it out of the other material that has to be this color. And that color, the base color would wear out well before the safety color.
Oh, very
So
much
the
so.
safety color would be the last thing to wear out. So the button would break before the color would go away, if is another way to say it.
Yeah. And I'm kind of actually crap. What the heck? Okay. Well, the thing is you can always print in, when you start talking about hardness, you start talking about like nylons, you start talking about polycarbonates, you start dealing with carbon fibers. I don't think we've gotten to the point yet where we're printing in Delrin. I don't think that's a viable platform yet.
Which it depends on what part of Delrin you're talking about. If we're talking Delrin for electrical applications, then that material is a little bit different. Mm-hmm. And then I think it's different versions of Delrin.
Yeah, I believe so.
But like if you're talking Delrin for a
Like shimming or anything like that. Yeah.
but say it's a more industrious material, I think that's a different formula.
Yeah.
I think it's the same family, but I think the formulas are different. But I think it can be done.
Yeah, eventually I think we'll see it, And the thing is as we speak, more and more and more different, materials are coming to light. There's people that are printing on powder bed fusion with Iconal. Iconal is what we use in rocket engines. Same thing that most companies use to build suppressors out of for any type of high performance firearms application. The thing is you're printing with very high performance, applications. It's like PC4 nylon now? PC4 nylon and carbon fiber and stuff like that is exactly what they're using in race applications. Building, heat resistant, headers and stuff like that for some of these, race applications.
I'll give you one. We talked about it 2 weeks ago. There is a company right now that is, so basically one of the most expensive things in a collision repair is the headlights.
Right.
And normally if the lens doesn't break, it's the clips that hold it in place. And then you have to buy a whole
new
enclosure.
headlight.
Well, there's a company that's made a kit that they can make these fixtures or make these adapters that can go onto your light, your headlight,
Okay.
and it mounts back up. So they're actually making the replacement part. So you buy just the replacement part, and you take the lens and the electronics and snap it in. So they're printing this, as a cost-effective measure, so that you don't have to replace the whole headlight. And that's actually having an impact on the collision industry, because for them also that's a cost savings for them, and that's less things we have to put in the landfill.
Right. And the thing is, if you think about it, speaking of that, if you think about it, you have these guys who have the older, like, say, Lamborghini Murcielagos, or, the pre-versions of those, stuff like the LP4Cs and whatnot, where a broken headlight is $10,000. You break a tip on one of those things, it's 10 grand. If you can save that money, and keep one of these cars collector grade, because you're able to fix it to a collector grade, you just save that, that person $10,000-$15,000 when it comes down to part repair. You're already paying that anyways if you wrecked one of those cars. Especially if you're talking the Mercies and stuff like that, the LP4s, that was all pre-plastic headlight. So they're the flat front headlights, and they were made out of glass. It was real glass. If you pop a fixture on the back of one of those things, now you have to go, and you can only buy those things secondhand. You can replace that piece and smack it back on the car, reuse it. And you can put more of these cars back on the road.
And you can use scanning to scan those things to get CAD drawings if the CAD drawings don't exist. And then you could somebody could basically have an avenue to have a little niche market where they can make all of the plastic parts that fit the electronics, and you just sell, if that part is broken, you sell that part.
Right.
And you don't have to have $1 billion worth of inventory on hand. You can do it the same way they do when you do a customized shoe from Nike. You put an order in, it's a 2-week lead time.
And you think about it, and I know we're kind of getting a little bit off kilter here, but the lenses for anything, actually, at this point. You can actually take that, not in glass, but you can do it in resin, and 3D print these things out of hard impact resistant resin, clear resin that's crystal clear. And some people, like, for example, I had John print me off. It wasn't for me, it was actually for one of our buddies. He printed him off the Voron logo for his 3D printer. And his complaint was the resin was too clear because it was too bright. So you were able to make crystal clear automotive grade resin parts with a 3D printer. So what's stopping people from rebuilding the glass? There's already
the glass is a little bit different.
Well,
we hadn't got to the point on, unless you know.
Well, you're not printing in glass because I was watching one of the guys.
Oh, you just use it. I got you. So you're using
resin.
Yeah, I got you.
And the reason why I bring that up is one of the guys I've watched, he's rebuilt his own car. He's rebuilt cars and stuff like that. But he didn't like the headlights. He liked them off of a certain model. So you wanted the same model headlights to fit the car he was building because it kind of flowed with the body lines and stuff like that.
Once again, there's another niche market.
He was able to scan the front of the vehicle, rebuild these headlights, and 3D print the lenses. Using a additive manufacturing approach, and was able to wet sand everything down and make them crystal clear. You don't even know they're not glass. Because the thing is right now in this day and age, good luck finding headlights that are glass anymore. You're not finding any, even the Bentleys and all of them, Rolls Royces, and stuff like that, are not glass. They're plastic.
Yeah.
It don't even get started on the Bugattis because those things are just high class VWs. But even they're using plastic. And they're a high horsepower, high performance, high speed vehicle. But the thing is you can retake, especially for like customization. I can 3D print tinted, crystal clear tinted, lenses using a resin 3D printer. that's you can still see through.
Yeah.
However, they're tinted from the outside looking in.
Yeah. So I would say, so your buddy, it was a real simple fix for that.
Yeah, yeah. He just darkened it up. He just sanded it a little bit.
You
Knocked
didn't
it down
have to
a little
sand
bit.
it. You take a deflector.
No, that's what that was.
No, I'm saying you take the material.
Yeah, yeah.
You cut out a material that's red, orange, whatever. The same thing we do in cars.
Yeah.
You put it behind there, and that diffuses the light. It's a
Yeah.
diffuser. So
Yeah.
all you have to do is take a piece of material that was whatever you wanted to diffuse it with and put that on there.
Yeah.
Just as a note, I'm just saying.
He hit it. He darkened it up with a little bit of sandpaper, knocked it down a little bit, like machined down a little bit of sandpaper.
That's one method, but like I said, most of them, if you look, they put diffusers behind them.
Yeah.
If you look at most lights in the construction of most headlamps, there's a diffuser behind it, and that's also a reflective element also.
Yeah.
So that it concentrates the beam of light, depending on if you're using low beam or high beam, blah, blah, blah. That application was not that. That application was something that it was a more of a, hey, I want some fancy lights, or I want this thing added.
Right.
I'm saying, like, there are different approaches to taking with additive manufacturing where you don't have to recreate everything. You can take the techniques that we used in the past and add that.
Right.
The other thing I would add to anything like that when we're talking about for me, I look at additive manufacturing a little bit different from people that look at it from the point of, hey, I can print something. I look at it from the point that, hey, okay, maybe this is the thing I can use that reduces the cost for me to make something that I need to test, or it reduces the cost for me to make something that I need off the secondary market that is, outrageous to buy.
Yeah.
Or it's something that cannot be produced. The technology is gone. So I can, make a mold or whatever. Maybe you say we don't have glass, blah, blah, blah anymore.
Yeah.
Well, hey, maybe somebody makes a mold and say, well, hey, I want glass.
Yeah.
Here's an option. If you want to pay extra money, we can make you a glass lens for your headlight, if that's what you so choose.
And the thing is I've also looked at it as restoration. Somebody might be able to make parts like you said that we don't have anymore.
Yep.
But now, I was thinking about this one day, and this is kind of something what kind of brought me on to wanting to talk about this today. Is we have all of the older robots that are no longer viable because parts aren't available. Why can't we 3D print parts to bring those back to life? Their controllers may be older than most, and so they may have some open source software support on them. But you get some of these people who can resurrect like the original robots that were first originally came out with and stuff like that to show in museums and show for people to see and show the evolution of robotics. But we're using 3D printing to bring those back. They might not be functional.
Yeah, well, I mean,
Or they could be.
Well, I'm saying for a restoration point of view, I mean that's a valid point, and that's one of the things that a lot of makers are doing now. They're using 3D printing, whether it's kit batching. We're getting off a little bit, but I'm just telling you how people are using it now. They also use it in movie making. They do 3D printing for that. So maybe somebody needs to see something in a different scale. They don't want to pay somebody to be on a CNC machine. They can go to a 3D printer and put it in different scales. It doesn't have to be exact. I just need hey, what does this look like when I take a shot?
Right.
And this costs cents on the dollar compared to if I had a machinist. Which I mean, if you need a machinist application, then you do. But that's a lot of money.
Yeah. And the thing is I think that your additive and your subtractive are complementary manufacturing devices, and that's when I think that when it comes down to ecosystems, you start dealing in that too, because the one ecosystem we didn't really talk about is the 3D printing support to the subtractive manufacturing ecosystem, because that's when you start dealing with soft jaws. That's when you start dealing with stuff that, like hold down clamps, stuff that's if you hit it with an end mill or something like that, whatever, go rebuild it. Hit the print button again on a on an endurance, go, make me soft jaws again, and so that type of stuff. I think that your hold down clamps, soft jaws, and all of this for subtractive manufacturing is also a really large push for the use of additive. For stuff that people either may not be able to afford because soft jaws aren't cheap, and most of the time when you have soft jaws, you got to build them yourself anyways. It's like the rotating what is it, the circle clamp? I think it was. I think we saw one at South Tech where it locks in like in a circle and locks into place. You can build that with a 3D printer.
Yeah, like I said, it's a lot of good applications we could use additive manufacturing. I say the biggest thing is there niche markets that could be I guess you could take advantage of, or I guess you could basically concentrate on. What maybe another thing you could use additive manufacturing for if I want to do draw organization, or if I want to maybe add clips or something for wire management, or it's a couple of things you can do. Like I said, the interesting thing about today's topic, like I said, we were talking about robotics and how we can incorporate it in additive manufacturing. I think the biggest thing is we have to look at it from what can we do today. Tomorrow it's no telling the potential of what we can do, but today I see some very unique opportunities. We could do things that could be used in a utilitarian way.
Oh yeah. There's definitely, I think as the years go by, the months go by at this point, the use cases open up more and more and more, and become more and more available, because we see the leap in additive manufacturing, we see the leap in subtractive manufacturing, we see the leap where those two are combined. We also see the leap where now we've incorporated additive manufacturing, subtractive manufacturing, and robotics all in one loop, instead of just being robotics and subtractive manufacturing. Because you start talking about tending and stuff like that, especially when you start talking about Haas, the machines coming out of Haas and Melt.io and stuff like that they do. Which, by the way, if you haven't taken a chance to look at that piece of equipment, kind of missing out. But the thing is, as we go month by month, year by year, the environment is going to change. The needs are going to change. You're going to start seeing more and more and more robotic companies going towards 3D printing to support their operations, and more 3D printing companies going to robotics to support their operations. So it's the self-licking lollipop ideal. But the thing is everybody's supporting each other, because everybody started an open source in one version or another. Because robots started out with because there was a need, and it started out as an open source event. 3D printing started out as a rep open source event. So you can build an open source robot, printed on a 3D printer. So the thing is, and I think one of the big key takeaways that we're going to come to tonight, and as we get close to the end, you can always use a 3D printer to print a robot to teach STEM. You can always go back to that. You don't have to go spend $9,000-$10,000 on a robot to teach STEM. You can 3D print your own. You can teach people how to work a robot, teach people how to program a robot, and influence the next generation of people that are coming behind the rest of us who are eventually going to be rolling out of the industry.
Yeah, I think that would be a good application of additive manufacturing to introduce people into robotics, and then maybe get into automation. For me, I truly believe that we got to focus on STEM. Always talking, the cores of STEM, but we we have to also look at, just like in, the ancient Egypt when they were building pyramids, they had masons, and the masons were, basically like technicians, and the technician was not the architect. We have to quit trying to teach everybody on the architect level, and we have to give the masons the tools to be able to create the um, um, artisans
Yeah.
for the next generation.
Yeah, which makes sense. And and I think as we get there, we're slowly but surely, coming across, everything that they need, we need. The next generation is going to need to want to learn stuff like that. And I think as we get there, the curriculum expands. The curriculum wants to expand. It needs to expand. You have companies out there supporting this process from Yaskawa from Kuka, ABB and Fanuc from the robot side. Then you also have Ender supporting on their side. You have the guys from all the major robot companies, not robot companies, but additive manufacturing 3D printing companies, Prusa Research and all of them that are getting behind on the educational side of the house. As we see a lot of these come to light and come together, we set the stage for advanced learning and quicker to job market than we have before. We don't have everybody being an engineer. We don't need everybody being an engineer. We still need people that want to be out there and tune these robots and and be with them on a daily basis. And because as we get away from the wrench turning maintenance tech to the more of an IT maintenance tech, as things change, we're going to see more and more of a need for people to understand how we build things and how we can repair things. But I think that kind of brings us to the end tonight. And I want to, start off by saying thank you. Thank you to everybody who's tuned in. 2,845, all-time downloads as of today. So we're definitely, we're going the right way. We've definitely been there. Didn't think we'd ever get this far, to be honest with you. I'm surprised some of y'all want to hear us talk. But we want to say thank you to every single person who's tuned in and listened to us jabber. We do it for fun. We do it to enjoy. We want y'all to enjoy it. We want y'all to learn something. Get out there and learn something. Go take a look at the blog, the Vulcanara blog. We're going to be active there here in a little bit. Got some stuff coming there. Go take a look at the YouTube channel, Vulcanara Technology Solutions. Go take a look there. And then, go take a look at Printed Heritage. Let us know if we can help you there. Especially with lithophanes and stuff like that. We're always willing to do something. And then hopefully soon we'll start getting a little bit more with a new logo coming out. We'll be able to do a little bit more merch on the Vulcanara 3D website, so people can get a hold of that. So, but first and foremost, above all rest, thank you to every single one of you who've tuned in to listen to us. From all over the globe. I wish I could sit down and say thank you to every single one of you personally, but we can't. And hopefully, we can see y'all at some of these shows. If you see us walk, if you see, I know you'll probably see me, but if you see me walking around, SEMA, stop me and say hello. Let's have a conversation. Let's talk about it. Same thing when you see us next year at Automate and at Rapid. If you see us walking around, stop us, have a conversation. It'll be more. We want to do that type of stuff. We want to get out and do a meet and greet with you. We want to do a couple giveaways with y'all. So, let us know you're there. Let us know what you want to hear. So, you know what? I say thank you, and I'll turn you over to Ed.
Yeah, so I'd just like to piggyback on what Nick said. We appreciate all the support, appreciate all of the people tuning in to listen. We started this, a couple of years back. It was basically, hey, why don't we do a podcast? And then from there we said, sure, why not? So for us, it truly is a thing of passion for us. We wouldn't do it if we didn't enjoy doing it. We would like to, maybe get to talk to some of the people in the community. Maybe give us some suggestions for things that you guys are interested in, because we like to talk about all kind of tech. It's not just 3D printing or robotics or automation. We have a vast amount of knowledge, from OT, IT, cyber, web development, MES. I mean, we have a really vast amount of knowledge, even from things from like video gaming. So we're open to any topics that you guys are interested in, and maybe in the future we'll do a couple challenges. We'll just we got some things working, and we'll let you guys know when it's available.
All right, y'all. Y'all have a good one, and talk to y'all later.
Yeah, thank you.
All right. That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.